Okay. So good evening. My name is Szymon Wojciechowski from Wrocław University of Science and Technology. And today I want to tell you about our work with my colleagues, also from my university, Joanna Komorniczak and Klikowski, and Michał, Choraś and Rafał Kozik from Bydgoszcz University, also from Poland. So our research is focusing on analysis of extractive text summarization and the methods as a binary classification problem. So first I will formulate the problem and tell you about the motivation for this work. Then explain how we used our data set and the experimental setup along with the results and conclusions coming from this research. So basically, why do we need to make the summarization of the texts? We are living in the times where the articles and the news are appearing online every day and in an increasing amount. So for most of the readers, we just need the relevant part of the text so we can be informed and we can stay up to date with what's happening in the world. So if we have the proper summarization, we are actually able to get the information faster, but what it brings us even more, if we can compare the text, if we can compare the sources by the summarization, we can verify our information easier, and we can verify this along multiple sources. So what we are doing here is extractive summary. And the extractive summary is based on selecting only the relevant parts of the text, which should not be confused with the other type of the summary generation, which is abstractive summary, and it contains of some generated parts. Choosing the extractive summary, we decided to formulate this as a classification problem, as we can say that if we have the original text and some summary prepared by a human expert, we can just label the sentences that it should be included in the summary or excluded. We conducted our research on BBC News summary dataset. This dataset is available online on the Kaggle platform, and it contains more than 2,000 texts, along with the summaries prepared by the BBC authors. And the articles are divided into 5 categories in which we conducted our experiments. We set some baseline preparation for our documents, such as we separated this by the sentences, we ignored the double white spaces and special characters, and this was both applied to both texts, and also, as I said before, if the sentence that we obtained in our dataset preparation was included in a summary, we choose to label it as the positive class, so to be included, and if not, it was the negative class. So let me start with the dataset analysis, which we did. We can see, I hope we can see, that the medium size of the text is around 20 sentences. It's very rare to have more than that. And if we look at the summary, which is on the right side, it's your right side, we expect it to be about half of the original text, or as you can see, it's even 0.4 of the original text, which is also very important information because this gives us the knowledge that actually our problem is fairly balanced. If we choose just half of the sentences, we can expect that both classes are balanced, so we don't have to struggle with difficulties of the imbalanced data set. We can just treat this as classic, let's say classic classification problem just with the extra NLP steps. And getting to that, first of all, if we are working with the text data, we need to process it to the form which is representable for the classification model as we want to train it. So we choose this setup of the parameters for our experiment just to find the best of the base classifiers that could handle our problem. So we used three types of vectorizers, all of them based on the term counting and the term frequency analysis. We also choose the feature extraction, as often vectorizers produce a large feature space. We desired it to have three possible reduction sizes of 5, 15, and 25 features, and we choose two methods. And of course, the set of the base classifiers that will be used as a model for the decision making. Also, there is one important thing. We decided to make the vectorization along a single article, so we build this along the vocabulary used in the singular one, and also to build this as a vocabulary from the whole category in which the article was published. For the evaluation method, we used the leave one out protocol based on a single article. So if we had an article that was containing 20 sentences, we're choosing one in sequential, used 19 to train the model, and one to choose if it should be included or should be excluded from the summary that we want to prepare. And as I said before, because this problem is balanced, very balanced, we use the accuracy metric for evaluation. Okay, so this is cumulative results. And from what you can find here is that, the results that we obtained are fairly good, because we can say that most of the times, most of the methods in each category obtained fairly good accuracy. And we can actually choose for each category the best model in which we want to, which we can use to obtain a good summary. However, as I said this before, this was done on a single article. So if we take a better look to the classifiers on the whole category, we can see that the distribution of these accuracy metrics along the singular articles is slightly shifted. If we used the vectorizers based on a single article, which is the orange color here on the plots, we obtain the similar values that I showed you in the previous table. But if we use the vectorizer based on whole category, it's slightly shifting more to the level of 0.6, let's say 7, sometimes of the accuracy obtained on the whole articles. So in conclusions, after this research, we can say that the models that we built are actually capable of doing the summary of the text. And we can say that we can define this problem as a classification task. We also see that the feature extractors or feature selectors based on the rank are working better. And that making these classifiers is fairly better if we train these classifiers on a singular article. In extension, we see this method as a possible tool for supporting fake news annotation, as summaries along the multiple sources can be used for the annotators to make the decision faster, even to find the other sources of the information that can validate the data without spending a lot of time for just the reading of the text, just to make the annotators' works easier and faster. Thank you very much. That will be all. And I hope there will be some questions. Thank you.
Question? Then, actually, I have one question. It is related with the last item in the conclusion.
Mm-hmm.
You mentioned that this work is directly related with detecting fake news or something. Can you explain a little bit more? If we use that summarization, why it can be helpful for detecting fake news?
Okay, so Basically, to obtain the data set with the fake news annotations, we need to have some human expert, which will decide whether it's a fake news or not, to check the facts. If our annotator has some sort of database of the texts, he needs to read them all. If he has the summarization, it is easier for him to read all of them, first of all, and second of all, he's doing this not just once, but he's doing this over the time. So summarizations are important, can be important to the annotator, so he keeps tracks of the news.
Thank you. And also second implication is a little bit tricky in some sense, you know, that is just a conventional way of thinking in machine learning. So
yeah, sorry, this is just written wrong, yeah.
Okay, anyway, thank you for the nice talk.
Thank you.